The parallel universe theory, often referred to as the multiverse theory, suggests that there are multiple, perhaps infinite, universes existing alongside our own. These universes may have different physical laws, constants, and even different versions of reality. The theory is based on various interpretations of quantum mechanics, cosmology, and string theory, with several main ideas. 1. Many worlds interpretation. This interpretation of quantum mechanics proposes that every time a quantum decision is made, like a particle being in one state or another, the universe splits into different versions, each representing one of the possible outcomes. 2. Cosmological multiverse. This theory suggests that our universe is just one of many that were created during the Big Bang, and each universe might have different initial conditions, leading to different forms of matter and physical laws. 3. String theory multiverse. In string theory, the fundamental building blocks of the universe are tiny vibrating strings. This theory proposes that there are many possible ways these strings can vibrate, leading to different versions of universes with different physical properties. The parallel universe theory is still speculative and lacks empirical evidence, but it presents fascinating possibilities about the nature of reality and our place in the cosmos. Let's dive deeper into the concept of parallel universes from various scientific, philosophical, and speculative perspectives. We'll explore the implications, the arguments for and against, and how this idea ties into broader questions about the nature of reality. 1. Many worlds interpretation, MWI, of quantum mechanics. The many worlds interpretation, MWI, formulated by physicist Hugh Everett III in 1957, is one of the most prominent ways that quantum mechanics links to the idea of parallel universes. It suggests that all possible outcomes of a quantum event happen, but each in its own separate, branching universe. Quantum superposition. In quantum mechanics, particles like electrons can exist in multiple states at once, a phenomenon called superposition. For instance, an electron can exist in a superposition of spinning both clockwise and counterclockwise at the same time. Wave function collapse. Traditionally, the wave function that describes these states collapses into one state when observed. However, in MWI, instead of collapsing, every possible outcome of a quantum event happens, but in a different branch or parallel universe. For example, when you flip a coin, the universe splits into two, one where it lands heads and one where it lands tails. Decoherence. As these universes evolve, they become increasingly isolated from each other. This separation is called decoherence. It's not that we can see the other universes, but rather that the quantum interactions have made them fundamentally different from our own. Implications. The MWI effectively removes the randomness inherent in quantum mechanics by suggesting that all outcomes are realized, but not in the same universe. Philosophical implications include the question of whether these branching universes are conscious and whether we in these parallel worlds have different versions of ourselves making different decisions. 2. Cosmological multiverse, bubble universes. The cosmological multiverse is inspired by the theory of cosmic inflation, a period of extremely rapid expansion that occurred just after the Big Bang. The theory was first proposed by Alan Guth in the 1980s and has since been refined. Inflation. During the inflationary period, spacetime expanded faster than the speed of light, creating vast regions of space. According to the theory, different regions of space can stop inflating at different times, leading to the creation of distinct pocket universes. These bubble universes may have different physical laws, constants, and even dimensions of space and time. Eternal inflation. In the eternal inflation model, some regions of space continue inflating while others stop, creating an endless bubble of universes. Each of these universes could have different outcomes based on random fluctuations during inflation. Inflation. Implications. This version of the multiverse suggests that our universe is just one of many that arose from the same fundamental processes. Our laws of physics and constants, such as the speed of light or the strength of gravity, may simply be the result of where our bubble universe formed in the larger multiverse. The implications for the fine-tuning of the universe are significant. The fine-tuning problem asks why the constants of physics in our universe appear to be so perfectly balanced for life to exist. The multiverse theory suggests that, with many universes, it's not surprising that at least one would have the right conditions for life. 3. String theory and the landscape multiverse. String theory is a theoretical framework that attempts to describe all fundamental forces and particles as one-dimensional objects, strings, vibrating in multiple dimensions of spacetime. It proposes that the physical universe could have up to 11 dimensions, some of which are hidden from us. Vacua and the landscape. One of the key insights from string theory is that there are many possible ways in which the extra dimensions can compactify or fold into smaller spaces, leading to different vacuum states. Each of these states can result in a universe with its own laws of physics. These different states are called vacua and make up the landscape of possible universes. Anthropic principle. Some proponents of the string theory-based multiverse argue that our universe's specific properties are the result of our particular vacuum state being conducive to life. In a multiverse scenario, there could be a vast number of different universes, some with vastly different laws of physics that make life impossible, and others with conditions that support different forms of life. Implications. String theory-based multiverses imply that the physical laws we observe might not be unique, but one possible realization of an infinite number of potential realities. The landscape of possible universes could be vast, with different constants, forces, and even different numbers of dimensions, potentially leading to universes that are radically different from ours. Philosophical implications of this scenario include the idea that the existence of life in our universe is not a miracle, but one of many possibilities. 4. Mathematical universes, Tegmark's hypothesis. In Max Tegmark's mathematical universe hypothesis, all structures that can be described mathematically exist in some form as their own distinct universe. According to Tegmark, if a structure can be expressed by a mathematical equation, it corresponds to a real physical universe. Platonism and reality. Tegmark's hypothesis suggests that the universe is not just governed by mathematics, it is mathematics. Every mathematically consistent set of laws and structures would correspond to a separate reality, even if those structures are radically different from the physical laws we experience. Infinite possibilities. Under this view, all possible mathematical structures, and by extension, all possible physical laws, exist as separate universes. The variety of possible mathematical worlds could be as vast as the number of different mathematical solutions that can exist. Implications. If true, it means that every mathematical possibility, no matter how bizarre or impossible from our perspective, represents a distinct universe with its own reality. This has significant metaphysical implications, as it would imply that the entire structure of reality is mathematical in nature, raising questions about the nature of consciousness, existence, and the meaning of physical reality. 5. Parallel universes in fiction and philosophy. Parallel universes are also a popular theme in science fiction, where they explore alternate timelines, realities, and histories. Fictional portrayals of parallel universes often focus on the idea of alternate histories, like the TV show The Man in the High Castle, where the Axis powers won World War II, or parallel lives, as seen in movies like Sliding Doors or Doctor Strange. Alternate timelines. Many works of fiction explore the idea of what-if scenarios, where a small change in history results in drastically different outcomes. This ties into the multiverse hypothesis, by suggesting that each decision or event might split the timeline into two or more diverging possibilities. Quantum decision-making. Fictional universes often depict characters who can jump between parallel worlds or experience versions of themselves making different choices, offering an emotional and philosophical exploration of fate, free will, and the self. Philosophical questions. Free will versus determinism. If parallel universes exist, do they support the idea of free will? In some interpretations, every possible outcome occurs in a different universe, but does this mean we have true freedom of choice, or is everything predetermined by the multiverse structure? Personal identity. If there are multiple versions of ourselves in different universes, does this mean that our identity is split across many realities? Are we the sum of all our potential selves, or does each version have its own independent consciousness? Challenges and criticisms of the multiverse theory. Lack of empirical evidence. One of the biggest criticisms of the multiverse theory is the inability to directly test or observe other universes. Since parallel universes are inherently unobservable by definition, it's difficult to prove or disprove their existence. Occam's razor. Some critics argue that the multiverse hypothesis violates Occam's razor, which states that when faced with multiple hypotheses, the simplest one is usually the best. The idea of a multiverse introduces many unnecessary entities without direct evidence. Philosophical issues. The notion of infinite parallel universes can raise philosophical dilemmas. If everything that can happen does happen in some universe, does that mean that every action is both right and wrong in some reality? It could challenge our sense of moral responsibility or undermine the significance of individual choices. In conclusion, the theory of parallel universes presents a rich and fascinating array of possibilities across various fields of thought, from quantum mechanics to cosmology to philosophy. While the scientific evidence for these theories remains largely speculative and unproven, they continue to inspire both academic inquiry and imaginative exploration.